So we got the date set?
So a few weeks ago, when I was preparing the event, I reached out to a few companies and people that we've been dealing with, and it was very interesting that MDOT responding very positively to that question, and where they would be able to present today and give us an intro on the connected vehicle initiative that they're running in southern Michigan. So I thought it would be a good lay of the land for us, and then Andy will describe our activities in the area of verification, validation, certification more exactly, and describe what we do in the area of DSRC testing. So without further ado, I'm going to invite Collin Castle. He's with MDOT, and Collin, it's your spot.
Sounds good, thank you. Yeah, so I'm Collin Castle. I'm with the Michigan DOT, and I'm in our statewide ITS program office. So essentially, it's implementing technology to improve things like safety and mobility and all that wonderful stuff. And today I'm going to cover what we're calling the Smart Corridor Initiative. Really, it's a large-scale kind of connected vehicle infrastructure and application deployment that's occurring in southeast Michigan. My current role right now, I focus on where this infrastructure is going to go, how do we use all of the data that's being supplied by the vehicles, and then how are we able to actually take that data from the vehicles, turn it into information, and provide it back to the motorists in valuable types of information to improve things like safety, mobility, allow us to do our job better, whether it be managing our pavement assets, completing winter maintenance activities. So I'll talk about a number of those things. So really, this is the main driver why MDOT is interested in connected vehicle technology, is the fact that what you've seen over the last several years is kind of a leveling out of traffic fatalities in Michigan. So in the early 2000s, you saw a pretty steep decline, and a lot of that was attributed to things like geometric roadway improvements, things like cable guardrail, just basic safety improvements that took care of those certain physical attributes of the roadway that created unsafe conditions. And what we found now is that now that we've solved a lot of those, there's still a lot of crashes that are occurring out on our roadway and fatalities that we feel we could try and take and remove essentially and move towards the zero deaths is using connected vehicle or new vehicle technology. So things like vehicle-to-vehicle and vehicle-to-infrastructure technology to try and really keep those deaths driving down toward that zero number that really I think everybody's striving towards. So I won't insult everyone's intelligence here, but I think we all know kind of what connected vehicles are. It's vehicles, the drivers of those vehicles. You have your wireless connectivity component, whether it be wireless handheld devices or the vehicle itself instrumented with some sort of communication technology, and then the infrastructure, things like traffic signals or other advanced types of travel information, like information about congestion or weather types of information. And the thing I want to talk about here when it comes to the kind of connected component is what you've seen from the US DOT is a large discussion about dedicated short-range communications, which is high-speed, low-latency communications, dedicated specifically for vehicle-to-vehicle and vehicle-to-infrastructure applications for safety. So a lot of the discussions about that type of communications, MDOT is also really interested in how we can take advantage of other widespread types of communication paths, things like cellular, to be able to collect data as well as provide information back to the motorists. So at ITS World Congress, September of last year, Mary Barra from General Motors announced what we're calling a Smart Corridor Initiative. We're actually in the process of kind of rebranding it. Smart Corridor is something that's been used a lot of other places, kind of generic, really doesn't tell you exactly what's going on, but what you do need to know is this, these lines essentially outline, a multi-year investment strategy that MDOT has to invest in connected vehicle roadside infrastructure and applications that'll essentially allow vehicles as they're either rolling off the assembly line or retrofitted to be able to communicate with the infrastructure. There's a couple reasons why we chose kind of this general area. One, you know, it has such a large presence of the auto industry, whether it be, you know, OEMs, tier 1 suppliers, you know, equipment manufacturers, research and development facilities. We know that these freeways and surrounding freeways in this area have real world problems that we're trying to solve, whether it be, you know, congestion, you know, things like real problems with, you know, recurring types of congestion that we're seeing out on the roadway, but being able to really implement technology in a location that has real world benefit for the motoring public. And, you know, the idea of why we chose kind of Southeast Michigan is the idea that if you deploy the infrastructure and the vehicles are, you know, becoming available, it kind of provides this nice marrying point where, you know, we've been challenged with the idea of how do you warrant deploying infrastructure that there's no vehicles to take advantage of it, and then from the vehicle side, you know, the OEMs are saying, well, why deploy vehicles if there's no infrastructure to support it? So if we focus on one general region, we deploy the infrastructure and the applications that vehicles can take advantage of, then you can start to see the first real-world, large-scale deployment of connected vehicle technology really in the world. So another kind of reason and supportive of why we chose Southeast Michigan is that there's been a lot of connected vehicle infrastructure research that's already taken place. So if you look down here near the Ann Arbor area, there was the US DOT Connected Vehicle Safety Pilot Model Deployment, which was, you know, the largest test of connected vehicle technology so far in the world. 3,000 vehicles, approximately 30 roadside units. Up along the kind of mixing bowl area where you have 96, M5, 696, 275. That area is where US DOT has done a lot of research with connected vehicle infrastructure. So things like the telegraph corridor where they've been broadcasting signal phase and timing information that vehicles can take advantage of. And then we also have the city of Detroit as a test bed which has been established specifically for purposes of trying to test unique situations that you see in urban areas, things like urban canyons, issues with GPS accuracy, things like that. So we've kind of shown you the general area. What are we going to do with the infrastructure? So it's really about applications. So what are we trying to accomplish to really improve you know, the experience for the motorist and improve safety? So there's a handful of things that went into us deciding, you know, what types of applications we're going to develop within the Southeast Michigan area. One, we had to look at, you know, what benefits the agency. So what types of applications are going to allow us to collect information, allows us to do our job better. And then also we have to look at it from the public's perspective. You know, what you know, types of applications can really benefit the public. The other component of that is really the industry's need and ability to use the infrastructure. So, like I said before, we've had this kind of chicken and egg with connected vehicle infrastructure, and the fact that if you deploy something that individuals aren't ready to actually take advantage of, then it's kind of a waste of investment. The other idea is application readiness. So MDOT spent a lot of time already focusing on how do we take advantage of this connected vehicle data and then turn it into usable information for the motorist. So we're really trying to take advantage of previous research that we've done in the past. And then finally data availability. So you know, if you're trying to, for example, you know, tell folks where congestion is or where queues are forming, if you have no data to support that, you know, there's no real way to have an application that's functional and provides any benefit. So here are the 5 that initially we're talking about focusing on. Just real quickly, I'll kind of, at a high level, signal phase and timing, red light violation warning. The idea here is broadcasting signal phase and so signal phase and timing, red light violation warning, road weather management, a work zone warning or management or reduced speed zone, a border wait time application due to our proximity to the international crossings and all of the freight movement, and then a pavement condition monitoring application. Like we talked about earlier, we know there's a lot of potholes out there. So, all right, so signal phase and timing red light violation warning. So the idea here is you have a DSRC roadside unit. It's connected to a signalized intersection controller. And what you're doing is you're broadcasting every 1/10 of a second the signal phase and timing information, whether it's red, yellow, or green. You know, vehicles can take advantage of that in a number of ways. So it could be some sort of like an environmental type of application where if the vehicle is approaching the intersection, they'd be able to hit it during the green band for environmental types of purposes. But then also we're looking at this idea of a red light violation warning. So if the vehicles are communicating with the roadside infrastructure and they're able to determine that a vehicle is approaching that could potentially violate that red light, we're able to broadcast some sort of a message to the other motorists that are instrumented, letting them know that there's a potential red light violator, as well as being able to notify the violator of the potential violation. So the idea here really is that you're providing a safety benefit to the motoring public, but then at the same time it allows us to start really looking at how our signals are timed to be able to understand, are there locations where the timing is unsafe? Are there locations where maybe we need to do a better job of timing our signals to be able to minimize congestion in queues that are forming, and then ultimately understanding how we can dynamically change our signals based upon real-world conditions. The next one is road weather management. So right now, MDOT spends a lot of its time really looking at kind of fixed types of data to be able to determine where we're going to go out and complete winter maintenance activities. So for example, we're looking at what we call environmental sensor stations. There's stations all over the state of Michigan that give us a pretty good representation of what's going on out on our roadways. We have our MDOT fleet instrumented with the ability to know, where we're completing, salting or plowing activities. But if we could start to take advantage of a larger fleet of vehicle data, we can then get a more real-time representation of, for example, if the roadway surface is wet, dry, or icy, and then be able to pinpoint locations where we need to take some sort of winter maintenance activities. And I'm speaking mainly to winter maintenance because it's not as much of an issue during the summer. I mean, you do have some large storm events, but mainly our focus is on trying to take advantage of connected vehicle data to, one, allow us to complete winter maintenance activities, but then two, be able to provide messaging to motorists about inclement weather types of scenarios. So it could be, you have blizzard or whiteout conditions. It could be that you have a slippery pavement surface. So it's kind of that idea of using the information and then, or using the data from the vehicles and supplying it back as information. Work zone warning management. So, everyone has seen the scenario where you drive up to the work zone and there's the message on the side of the road that says, work zone between the hours of this time to this time for these many days. It's like, well, that's not really great information. So the idea here is that we could take and provide the motorists with more robust information about real-time conditions of the work zone. So, what lanes are closed, what work activities are truly occurring in that work zone. What's the speed limit based upon those work activities? Is there any type of condition that the motorist should be aware of, whether it's slow or stop traffic? How many times have you come up into a work zone and there's dead stop traffic ahead of you and you're doing 70 miles per hour? So being able to provide that information to the motorist could be really valuable for their safety, but then at the same time, you can use that vehicle data to be able to, as an agency, determine, okay, well, how is this work zone impacting travel? Where do we have some sort of problematic condition that we need to try and address? So really the idea here is just better work zone information, to improve the motoring public's day-to-day drive. Another one is a border wait time application. So we've spent a lot of time focusing on how do you deploy infrastructure near the borders to be able to determine a wait time, for example. The idea here is that we can now use vehicle data to be able to determine real-time wait conditions and also be able to turn that information back to the motorist in a more detailed, kind of accurate representation of how long they're actually going to be at this international crossing. And the idea here is that you could instrument a number of crossings and vehicles could determine which crossing to utilize based upon those real-time wait conditions. I mean, right now, a lot of it is based upon the toll booth individual looking out and saying, well, the wait is this long, so I'm estimating it's X amount of minutes. Well, you could do some real calculations and be able to provide good information to the motorists. And then the wonderful one that MDOT gets beat up on all the time is the condition of our pavements. So there's a lot of great information that we can receive from vehicles in regards to identifying locations where pavement defects are forming. So the way it works today is that actually our kind of maintenance coordinators are the walking, I guess they're the walking or driving logger of where the defects are forming. So they drive around, they say, well, I know that this location has a whole lot of potholes. I think we need to do some maintenance activities there. And then every 2 years, we take a very highly instrumented vehicle and we drive around our entire system to get a really accurate representation of what's occurring out there. Well, the idea here is, can't we use our normal day-to-day MDOT fleet to be able to collect that information to allow us on a more real-time basis to be able to understand, what's occurring, and not only locations of where pavement defects are forming, but really the severity and the trending. So you could look at a certain location of pavement and see that it's aggressively trending in the wrong direction. Maybe you need to take a more aggressive action as far as maintenance activities. And then also we know that a lot of these defects, when they get to a certain severity, they have a serious impact on damaging people's vehicles. Even just being able to pinpoint those defects that have the potential to damage a vehicle could be something that's very important to us. All right, so what do we do with all of this data once it's collected? So over the past several years, MDOT has developed a system. The acronym is DUOP. It stands for Data Use, Analysis, and Processing, which is looking at how do you take all of these different types of connected vehicle or mobile data, kind of commingle it with other more traditional types of data within the department, whether it be pavement asset data, traditional types of ITS sensors, to be able to then develop a series of applications that meet different types of business process needs. So we went around to all the different areas within the department and said, hey, if you had this type of connected vehicle data, how could you use it? And then everyone kind of came up with these application concepts, and we've developed a system around a handful of those concepts to take advantage of this real-time data and be able to provide our employees with a better ability to monitor really what's occurring out on our roadways. So the initial applications that we focused on are a pavement application, a weather application, and a traffic application. And so each one of these, you can imagine our roadway kind of as a an asset. And over time, you want to be able to monitor the condition of that asset, and then you want to be able to be notified in an automated fashion of some sort of an event. So you think from a pavement perspective, you want to be able to monitor kind of the ride quality or smoothness of the roadway, but then you want to be notified of some sort of an event, whether it be a pavement defect. You want to know the severity, and you want to be able to identify where those locations are. Weather, we're monitoring the pavement surface as well as any type of weather that's occurring, but then we want to know of some sort of an event, whether it be an icy roadway condition or whiteout conditions, that we can provide information to the motorists. And then from a traffic perspective, you go on Google Maps and you see kind of the red, yellow, or green maps. Well, we want to know, when those red types of conditions are forming, and then we want to know, where are the queues forming, where is the congestion forming, what type of incidents are occurring. This system is helping us analyze a lot of that. So it's a web-based tool that everyone within the department has access to. And so you can see on the top couple screens there, screenshots, this is actual real vehicle data from one of MDOT's instrumented fleets. And through a set of thresholds that have been established, we can identify a certain signature means a certain type of pavement defect, and we're able to actually plop that on a map. So as a maintenance coordinator goes in and looks at their region, for example, they can see all of the locations where there's some sort of defect that they need to take action on. And on the right-hand side there, this is actually accelerometry that's on our vehicles. So based upon certain types of accelerometry signatures, we can actually identify exactly what type of pavement defect is occurring at a certain location. On the left-hand side there, these are a number of our left-hand kind of middle. This is showing a vehicle that's instrumented with the ability to collect a number of weather-related types of data, including things off of a CAN bus. And we also have the ability to take camera snapshots based upon certain conditions or thresholds that have been exceeded. So this is just showing you one of the vehicle's runs and kind of what one of the images looks like. On the right-hand side here, this is a weather-responsive traveler information system that we've developed. So we take all these different types of data into this system. We're actually able to identify affected areas where we can say, you know, okay, in this location we have, you know, blowing snow or snow-covered roads or icy roads. Just being able to, in real time, monitor our roadway from a weather perspective and understand where we need to, you know, complete some sort of activity. And then down here, these are just kind of a picture of our fixed traffic sensors. And on the right, this is just showing our ability to look at different segments of the roadway and monitor things like by-lane speeds, be able to know, you know, volumes, all kinds of wonderful stuff. And so, you know, what is MDOT doing from a vehicle perspective? We're actually turning some of our fleet into really connected vehicles. And so this is the overall architecture that we've come up with. VEDAS, it stands for Vehicle-Based Data Acquisition System. And if you just focus on the middle there, it's a little kind of Linux-based computer. And we have the ability to collect or install or connect a number of types of external sensors onto the dash. So on the right here, you see we have things like accelerometers and distance measurements for pavement surface condition information. We have the ability to collect a lot of weather-related types of elements. You know, we have the ability via Bluetooth to connect to the you know, OBD key, for example. And then, you know, you have kind of a number of different types of data elements that we can collect, whether it be wiper speed or you know, differential wheel speed to find slippery conditions, for example. But one of the interesting parts about the data acquisition system is that we have multiple communication paths based upon when we need the data. So if it's something like we want to know vehicle speeds, or we want to know, you know, if the roadway surface is wet, dry, icy, that's something we would send out over cellular because we need it in more real time. But then if there's something like a pavement defect, you may only want that, you know, once a day. So what we can do is drive our vehicles back to its home base and then just send that information out over Wi-Fi. And then when the DSRC, you know, infrastructure goes in, we can use the DSRC channel to start taking advantage of those types of applications.
I have a question.
Yep.
Where are your VEDAS placed? Inside the vehicle, on the roadside, or?
No, so this is in our vehicle. So the little data acquisition system essentially sits, you know, it's installed on a vehicle, and then the sensors are on different locations around the vehicle based upon the best location to collect that type of data. So accelerometry is actually on the rear axle. Distance measurement to see the distance from the vehicle body to the roadway, it's, you know, on the back part of the chassis. So yes, it's on the vehicles themselves.
With PCs, there's a Linux box?
What's that?
With PCs, a specialized
yeah, it's actually this Relegate 10-20, that's the model number. So. And then just from an overall smart corridor perspective, you know, there's a lot of needs we have. So we need vehicles and users, of course. There's no point in deploying something that no one's going to use. We're in the process of developing these applications for vehicle-to-infrastructure communication. We need backhaul. There's a lot of locations like signalized intersections where we need to be able to communicate with those signalized intersections to a back office, and currently we don't have that backhaul in place, so we need to deploy that. Security system, so with connected vehicle technology and DSRC, there's a security certificate management system that needs to be managed to determine when a vehicle is a, I guess, quote unquote,
Authenticated.
yes, authenticated user. And so MDOT doesn't intend on ultimately deploying that. And then partnering, we're really looking at business models that are out there, whether it be from telecommunications or equipment providers, different things that will help us deploy this thing faster and have benefit to the overall industry. So with that, here's my contact information, and thanks for letting me speak. Any questions or?
Thank you, Collin.